of older CR systems have solenoid-driven plungers for lifting the injection needle, whilst newer CR injectors use plungers driven by piezoelectric actuators that have fewer moving mass and therefore allow even more injections in a very short period of time. 182. Early common rail systems were controlled by mechanical means. The injection pressure of modern CR systems ranges from 140 MPa to 270 MPa. 183. Indirect injection. Ricardo Comet indirect injection chamber. An indirect diesel injection system, IDI, engine delivers fuel into a small chamber called a swirl chamber, pre-combustion chamber, pre-chamber or antechamber, which is connected to the cylinder by a narrow air passage. Generally the goal of the pre-chamber is to create increased turbulence for better air forward/fuel mixing. This system also allows for a smoother, quieter running engine, and because fuel mixing is assisted by turbulence, injector pressures can be lowered. Most IDI systems use a single orifice injector. The pre-chamber has disadvantage of lowering efficiency due to increased heat loss of engine's cooling system, restricting the combustion burn, thus reducing the efficiency by 5–10%. IDI engines are also more difficult to start and usually require the use of glow plugs. IDI engines may be cheaper to build but generally require a higher compression ratio than the DI counterpart. IDI also makes it easier to produce smooth, quieter run engines with a simple mechanical injection system since exact injection timing is not as critical. Most modern automotive engines are DI, which have the benefits of greater efficiency and easier starting. However, IDI engines can still be found in the many ATV and small diesel applications. 184. Indirect injected diesel engines use Pintle-type fuel injectors. 180. Air blast injection. Typical early 20th century air blast injected diesel engine, rated at 59 kW. Early diesel engines injected fuel with the assistance of compressed air, which atomized the fuel and forced it into the engine through a nozzle, a similar principle to an aerosol spray. The nozzle opening was closed by a pin valve actuated by the camshaft. Although the engine was also required to drive an air compressor used for air blast injection, the efficiency was nonetheless better than other combustion engines of the time. 53. However, the system was heavy and it was slow to react to changing torque demands, making it unsuitable for road vehicles. 185. Unit injectors. A unit injector system, also known as pump dose, pump nozzle in German, combines the injector and fuel pump into a single component, which is positioned above each cylinder. This eliminates the high-pressure fuel lines and achieves a more consistent injection. Under full load, the injection pressure can reach up to 220 MPa. 186. Unit injectors are operated by a cam and the quantity of fuel injected is controlled either mechanically, by a rack or lever, or electronically. Due to increased performance requirements, unit injectors have been largely replaced by common rail injection systems. 163. Diesel engine particularities. Mass. The average diesel engine has a poorer power-to-mass ratio than an equivalent petrol engine. The lower engine speeds, RPM, of typical diesel engines results in a lower power output. 187. Also, the mass of a diesel engine is typically higher, since the higher operating pressure inside the combustion chamber increases the internal forces, which requires stronger, and therefore heavier, parts to withstand these forces. 188. Noise, diesel clatter. The distinctive noise of a diesel engine, particularly at idling speeds, is sometimes called diesel clatter. This noise is largely caused by the sudden ignition of the diesel fuel when injected into the combustion chamber, which causes a pressure wave that sounds like knocking. Engine designers can reduce diesel clatter through indirect injection. Pilot or pre-injection winking sad smiley 189, injection timing, injection rate, compression ratio, turbo boost, and exhaust gas recirculation, EGR, dot, 190, common rail. Diesel injection systems permit multiple injection events as an aid to noise reduction. Through measures. Engine noise of a 1950 SMW MAKD 112Z two-cylinder diesel engine. A tittle such as these, diesel clatter noise is greatly reduced in modern engines. Diesel fuels with a higher cetane rating are more likely to ignite and hence reduce diesel clatter. 191, cold weather starting. In warmer climates, diesel engines do not require any starting aid, aside from the starter motor. However, many diesel engines include some form of preheating for the combustion chamber, to assist starting in cold conditions. Engines with a displacement of less than 1 liter per cylinder usually have glow plugs, whilst larger heavy-duty engines have flame start systems. 192. The minimum starting temperature that allows starting without preheating is 40 degrees Celsius for pre-combustion chamber engines, 20 degrees Celsius for swirl chamber engines, and 0 degrees C for direct injected engines. In the past, a wider variety of cold start methods were used. Some engines, such as Detroit diesel engines, used a system to introduce small amounts of ether into the inlet manifold to start combustion. 193. Instead of glow plugs, some diesel engines are equipped with starting aid systems that change valve timing. The simplest way this can be done is with a decompression lever. Activating the decompression lever locks the outlet valves in a slide down position, resulting in the engine not having any compression and thus allowing for turning the crankshaft over with significantly less resistance. When the crankshaft reaches a higher speed, flipping the decompression lever back into its normal position will abruptly reactivate the outlet valves, resulting in compression. The flywheel's mass moment of inertia then starts the engine. 194. Other diesel engines, such as the pre-combustion chamber engine 12JV170/240 made by Gans and Company, have a valve timing changing system that is operated by adjusting the inlet valve camshaft, moving it into a slight late position. This will make the inlet valves open with a delay, forcing the inlet air to heat up when entering the combustion chamber. 195. Supercharging and turbocharging. 1980 BMW M21 passenger car turbo diesel engine forced induction, especially turbocharging, is commonly used on diesel engines because it greatly increases efficiency and torque output. 196. Diesel engines are well suited for forced induction stops due to their operating principle, which is characterized by wide ignition limits, 142, and the absence of fuel during the compression stroke. Therefore, knocking, pre-ignition or detonation cannot occur, and a lean mixture caused by excess supercharging air inside the combustion chamber does not negatively affect combustion. 197. Fuel and fluid characteristics. Diesel engines can combust a huge variety of fuels, including several fuel oils that have advantages over fuels such as petrol. These advantages include low fuel costs, as fuel oils are relatively cheap. Good lubrication properties. High energy density. Low risk of catching fire, as they do not form a flammable vapor. Biodiesel is an easily synthesized, non-petroleum-based fuel, through transesterification, which can run directly in many diesel engines, while gasoline engines either need adaptation to run synthetic fuels or else use them as an additive to gasoline, for example, ethanol added to gasohol. In diesel engines, a mechanical injector system atomizes the fuel directly into the combustion chamber, as opposed to a Venturi jet in a carburetor, or a fuel injector in a manifold injection system atomizing fuel into the intake manifold or intake runners as in a petrol engine. Because only air is inducted into the cylinder in a diesel engine, the compression ratio can be much higher as there is no risk of pre-ignition provided the injection process is accurately timed. 197. This means that cylinder temperatures are much higher in a diesel engine than a petrol engine, allowing less volatile fuels to be used. The MAN 630 SM system diesel engine is a petrol engine, designed to run on NATO F46/F50 petrol, but it also runs on jet fuel, NATO F40/F44, kerosene, NATO F58, and diesel engine fuel, NATO F54/F75. Therefore, diesel engines can operate on a huge variety of different fuels. In general, fuel for diesel engines should have a proper viscosity, so that the injection pump can pump the fuel to the injection nozzles without causing damage to itself or corrosion of fuel line. At injection, the fuel should form a good fuel spray and it should not have a coking effect upon the injection nozzles. To ensure proper engine starting and smooth operation, the fuel should be willing to ignite and hence not cause a high ignition delay. This means that the fuel should have a high cetane number. Diesel fuel should also have a high lower heating value. 198. Inline mechanical injector pumps generally tolerate poor quality or biofuels better than distributor type pumps. Also, indirect injection engines generally run more satisfactorily on fuels with a high ignition delay, for instance, petrol, than direct injection engines. 199. This is partly because an indirect injection engine has a much greater swirl effect, improving vaporization and combustion of fuel, and because, in the case of vegetable oil type fuels, lipid depositions can condense on the cylinder walls of a direct injection engine if combustion temperatures are too low, such as starting the engine from cold. Direct injected engines with an unmanned center sphere combustion chamber rely on fuel condensing on the combustion chamber walls. The fuel starts vaporizing only after ignition sets in, and it burns relatively smoothly. Therefore, such engines also tolerate fuels with poor ignition delay characteristics, and, in general, they can operate on petrol-rated 86 RON. 200 fuel types. In his 1893 work Theory and Construction of a Rational Heat Motor, Rudolf Diesel considers using coal dust as fuel for the diesel engine. However, Diesel just considered using coal dust, as well as liquid fuel sound gas. His actual engine was designed to operate on petroleum, which was soon replaced with regular petrol and kerosene for further testing purposes, as petroleum proved to be too viscous. 201. In addition to kerosene and petrol, Diesel's engine could also operate on liquid. 202. Before diesel engine fuel was standardized, fuels such as petrol, kerosene, gas oil, vegetable oil and mineral oil, as well as mixtures of these fuels, were used. 203. Typical fuels specifically intended to be used for diesel engines were petroleum distillates and coal tar distillates such as the following. These fuels have specific lower heating values of diesel oil, 10,200 kcal times kilogram 1, 42.7 mJ times kilogram 1, up to 10,250 kcal times kilogram 1, 42.9 mJ times kilogram 1. Heating oil, 10,000 kcal times kilogram 1, 41.8 mJ times kilogram 1, up to 10,200 kcal times kilogram 1, 42.7 mJ times kilogram 1. Coal tar creosote, 9,150 kcal times kilogram 1, 38.3 mJ times kilogram 1, up to 9,250 kPa times kilogram 1, 38.7 mJ times kilogram 1. Kerosene, up to 10,400 kPa times kilogram 1, 43.5 mJ times kilogram 1. Source SAD Smiley 204. The first diesel fuel standards were the DIN 51601, VTL 9140-001, and NATO F54, which appeared after World War II. 203. The modern European EN 590 diesel fuel standard was established in May 1993. The modern version of the NATO F54 standard is mostly identical with it. The DIN 51628 biodiesel standard was rendered obsolete by the 2009 version of the EN 590. FAME biodiesel conforms to the EN 14214 standard. Watercraft diesel engines usually operate on diesel engine fuel that conforms to the ISO 8217 standard, bunker C. Also, some diesel engines can operate on gases, such as LNG. 205. Modern diesel fuel properties. Modern diesel fuel properties. 206. EN 590, as of 2009, EN 14214, as of 2010, ignition performance greater than or equal to 51 cN greater than or equal to 51 cN density at 15 degrees C 820, 845 kg times M 3860, 900 kg times M3 sulfur content less than or equal to 10 mg times kilogram 1 less than or equal to 10 mg times kilogram 1 water content less than or equal to 200 mg times kilogram 1 less than or equal to 500 mg times kilogram 1 lubricity 460 M460 viscosity at 40 degrees C 2.0, 4.5 mm 2 times S 13.5. 5.0 mm 2 times S1 FAME content less than or equal to 7.0% greater than or equal to 96.5% molar H/C ratio 1.69 lower heating value 37.1 mJ times kilogram 1. Gelling. DIN 51601 diesel fuel was prone to waxing or gelling in cold weather. Both are terms for the solidification of diesel oil into a partially crystalline state. The crystals build up in the fuel system, especially in fuel filters, eventually starving the engine of fuel and causing it to stop running. 207. Low output electric heaters in fuel tanks and around fuel lines were used to solve this problem. Also, most engines have a spill return system, by which any excess fuel from the injector pump and injectors is returned to the fuel tank. Once the engine has warmed, returning warm fuel prevents waxing in the tank. Before direct injection diesel engines, some manufacturers, such as BMW, recommended mixing up to 30% petrol in with their diesel by fueling diesel cars with petrol to prevent the fuel from gelling when the temperatures drop below 15 degrees C. 208. Safety. Fuel flammability. Diesel fuel is less flammable than petrol, because its flash point is 55 degrees C, 207, 209, leading to a lower risk of fire caused by fuel in a vehicle equipped with a diesel engine. Diesel fuel can create an explosive air/vapor mix under the right conditions. However, compared with petrol, it is less prone due to its lower vapor pressure, which is an indication of evaporation rate. The Material Safety Data Sheet, 210, for ultra-low sulfur diesel fuel indicates a vapor explosion hazard for diesel fuel indoors, outdoors, or ensures. Cancer. Diesel exhaust has been classified as an IARC Group 1 carcinogen. It causes lung cancer and is associated with an increased risk for bladder cancer. 211. Engine runaway, uncontrollable overspeeding. See diesel engine runaway. Applications. The characteristics of diesel have different advantages for different applications. Passenger cars. Diesel engines have long been popular in bigger cars and have been used in smaller cars such as Superminis in Europe since the 1980s. They were popular in